Hello, my name is Dominika Bobik, and I have been working on the modular project under advisory of Dr. Leo Euro. This project has been sponsored by Undergraduate Research Internship Program. In the growingly digital world, children are expected to start developing computational skills almost as soon as they start school. This starts with computational thinking, which can be taught at any age and doesn't start with coding or other skills traditionally associated with computer use. Our central hypothesis is that students engaged in computational modeling and simulation in a science course are learning and applying computational thinking skills. To test that hypothesis, we have created the Modeler, which is a simulation tool designed for the teachers with a heavy focus on the student needs. Our goals are, first of all, to introduce computational thinking in the STEM classroom. Second of all, engage interest in the still widely neglected but yet crucial computer science education. Finally, to deepen the understanding of the surrounding world. This project will provide teachers with a new and effective way to teach students of all ages. Modular can help teach interdisciplinary skills, merging computational thinking with the already existing STEM curriculum. It can be accessed under the following link, as it is a web-based application. And with that said, let's proceed to the short demo. Students are able to create accounts. I have already created one for the purpose of this demonstration. The key component of the app will be a center workspace where teachers and students can create the desired models by adding the components using the buttons on the left side. I have prepared a concept map that visualizes the photosynthesis process, which is a common process taught in STEM classrooms. Students then, upon adding the components, will be able to connect them with each other, add names, as well as change any properties desired. After that, students will pick a process they'd like to model. They can either use the tool as a standalone client to just create a concept map they wish, or they can use it to work with the predefined processes, like in our case, photosynthesis. If student chooses the predefined process, the software will calculate the quantities of the reactants based on the mathematical model that has been created by our students in our research group. Then students can proceed and interact with the visual simulation of the process. This work is still ongoing. And finally, they will be able to interact with the Analyze page that includes graph, equations, and information about the process. Work on the modeler is still ongoing. We have partnered with teachers around Michigan who have expressed interest in testing the tool in their classrooms. We plan on collecting feedback from students as well as the teachers and analyzing the received responses. At the end, I'd like to highlight people whose contribution has been crucial to the success of this project. Trevor, Austin, Nolan, and Rhys all worked on the technical aspect of the project. Ina and Katie were responsible for designing a user interface and making sure the tool is accessible. Rodney and Mira worked on the modeling of the processes. Thank you.